Now let's take a look at how we can store some of that back-end data that we're going to be generating with our phenomenally successful front-end websites. A couple of things that we should know. There's different ways we can store data, and we're going to break this down into several sections. But first, let's talk about storage for virtual machines, kind of like your disks and maybe file shares, that sort of a thing. That's one type of storage. The other is unstructured data. So when we're looking at things that aren't structured at all, documents, images, those can go in a couple of different places pretty natively. One is blob storage and one is data lake storage. And we'll talk a little bit about the difference in a moment. Structured data can go in a wide variety of things. There's a table function, basically just a big giant table where you can put a bunch of data in and it can hold it. It's very fast, very resilient to changes. It's a quick way to put it. And very much in your application, you'll have lots of tables potentially. There's things like DocumentDB, which we'll cover a little bit later, along with Azure SQLDB. And SQLDB is the relational, DocumentDB is the non-relational data stores available right out in Azure. And then things like SQL Data Warehouse, which are large-scale data warehouses where you don't pay for compute when you're not using the warehouse, but you only pay for it when you're running them. Now, let's go back a moment, just up above on the slide, and take a quick look at data lake storage. Data lake storage is big storage potentially for lots of very large files potentially. So whereas blob stores are limited when you create a container, the blob stores are limited to, I believe, 20 terabytes or something like that. I should really look that up again. They keep growing, but they're limited in size. Data lake stores can grow as big as you need. In fact, you could have one file in a data lake that is dozens or hundreds of terabytes in size. Now, is that a good idea? Probably not. But data lake stores and blobs provide this nice way to drop this unstructured data for later analytics. What's also nice about the data lake store, and I'm bringing it home here because I don't get to talk about it much later, is that it's paired with Data Lake Analytics. And Data Lake Analytics is a SQL-like query language service that runs on top of the store and can do analytics for you against all of this unstructured data. Very powerful pair of tools, Data Lake Store with Data Lake Analytics. But let's dive more deeply into the core data storage. And the core data storage really are these 5 things. And looking at the slide, you'll see those 5. They're blobs, tables, queues, disks, and files. And when you get a storage account in Azure, these are the things that you'll be looking for. Blobs, highly scalable. You can access them via REST. Tables, again, another NoSQL store. Dynamically scaling based on load. You can put petabytes of data in here. Very fast key value lookups. Nice ways to store and access some semi-structured or structured data. Queues are a reliable queue to help you scale cloud services. And I want to stop here for just a moment because queues are something that it's very important for us to understand when we're architecting for the cloud. You want to plan for things like intermittent outages. You might be making a call to something that might actually fail, and through no fault of your own. It's just some transient failure has occurred somewhere along that chain, and it causes a failure. Well, queues help separate 2 portions of your applications with something highly reliable in between. So one chunk of your app will make a call through a queue. It'll just drop messages in a queue so it can be processed asynchronously later. So even when you're not looking at scaling the consumer of those queues like you might be thinking, but simply just connecting 2 items, it's a very reliable way to make calls in something like Azure and all of the other cloud providers that might have intermittent failures that might come back and haunt you. And so we use queues to help separate those. Then there's 2 on the far right side, disks and files. Disks are used inside of Windows and Linux VMs on Azure. They're built on sides of page blobs, but basically we can set up the kind of disks we want to run our operating system on. And then there's files, which allow us to create these file shares that we can simply attach to one or many virtual machines. Helps for that kind of lift and shift of those legacy apps. So the storage services, those are the ones that you buy when you get a storage account. All these things appear in here. And they're core and fundamental to the way Azure works. Table stakes, right? You've got to have the ability to store things. Now, when we talk about storage, a lot of people freak out. Well, how do I know I'm not going to lose my stuff? Do I need to do a backup on premises? And the answer is no. Azure Storage has a lot of different options for you, and I'd like to walk through 3 of those ways that we can get durability. And if you take a look at the slide, the first thing you're going to see is LRS. This is locally redundant storage. And here we've got 3 replicas, but it's all in the same region. So if the west region of the US fell off into the ocean or something happened crazy, you would lose all that data. But it's 3 copies in one region, potentially in one data center. That helps protect against failures of like disks, the rack failures, etc. And they don't acknowledge the write until all 3 of those writings have been complete. So the nice thing is you know that it's really, really safe in one area with locally redundant storage. That's the cheapest of these 3 that I'm talking about. The next is globally redundant storage, and we get 6 replicas, 2 regions, 3 per region. So this now separates it out, and you have to go to another region, and there's some limits. It has to be like at least 300 miles away and some other things or whatnot, but within the same geo area so that you're not putting it outside of a data sovereignty place. So they're still within a data sovereignty area. And it's asynchronous to the secondary one. So you're going to primarily load it just like you do in LRS, but then it'll asynchronously replicate out to the global storage. And the last one is read access globally redundant storage. And this is very useful for when you're scaling out your infrastructure to have failover across geographical regions. So for instance, let's say you've got 2 geographical regions, and both of them depending on reading from some data store. Well, we'll just use West US and East US. When we write to West US, it replicates and shoots it to the read-only store on East US. And when East US is primarily writing, it'll write to a read-only copy in West US. So the applications running in East and West both have data to the cross things that people have entered, but both have data locally for extremely fast data access. So this is when you want to not only replicate geographically, but want to be able to read from those as well. So those are the 3 primary ways we have that durability. And frankly, that just gives you rock solid access to those. Why do we care? It's ideal for platform as a service to use something like blob storage. It's infinite. There's limitless scale. We can just keep hammering stuff in. And it's like Azure. It's like everything else. It just scales up to meet our needs. And you can use as little as you like and pay virtually nothing. Or you could use giant amounts of data and get limitless scale. It's globally accessible, and it's cost effective, and it's very, very fast. Some quick scenarios for how you might use it. You have a live data repository that needs to be accessed from everywhere. Could be a deep archive that you're using. Maybe you want to run big data analytics on these, and you want to put them in the cloud to support those types of big data analytics. All of those things are things that might be great usage for blob storage. I just want to tell one story for blob storage. We took a website that was hosted on 9 webheads and 9 IIS servers on the front end. And those had access to file storage in the back end. And when you hit a web page, it would go and grab all of the images and stream the images back out through IIS. Well, interestingly, when we lifted that off of on-premises and we lifted it up into the cloud, what we were able to find that Azure would do is we had that scale that we get from our website, but more importantly, all of those large image files, we moved, instead of being streamed through the website, we were able to access those via a direct HTTP or URL. So we moved those off onto blob storage and allowed the website to simply say, hey, go get this from blob storage. What were we able to do? Massively increase the performance of that website and run it through a very small instance of the website, because we were offloading all of the heavy lifting for serving these big images to Microsoft's very, very robust infrastructure to serve up blob storage. So not only are they wonderfully in limitless scale, but you're able to directly access them to get some benefits and architectures that's just not possible if it's stored on premises.